Aviation disasters are often attributed to extreme weather, terrorism, or sudden mechanical failure. The deadliest accident on United States soil resulted from a different kind of failure entirely. On the afternoon of May 25, 1979, American Airlines Flight 191 prepared for departure. The skies were clear, the runway dry. By every metric, it was a routine summer day. The aircraft was a McDonnell Douglas DC-10, one of the largest passenger jets of its era. On board, 258 passengers and 13 crew members settled in for the flight to Los Angeles. Catastrophic disasters are often assumed to have massive, obvious causes. Here, the destruction began with a sequence of errors that were nearly impossible to detect from the outside. At 3:02 p.m., Flight 191 accelerated down runway 32R. The engines reached full power, the nose lifted, and the departure appeared routine. But as the wheels left the ground, the left engine violently tore away from the wing, flipping up and over the leading edge. The pilots fought to maintain control, unaware of the scale of the damage. As the engine separated, it ripped through vital electrical wiring, crippling the cockpit warning systems that would have explained why the aircraft was failing. Without that data, the crew could not stabilize the plane. Within seconds, the left wing lost its lift, and the jet entered a sharp, unrecoverable roll to the left. 31 seconds after takeoff, the DC-10 slammed into an open field northwest of the airport. The impact triggered a massive fireball, claiming the lives of all 271 people on board and 2 others on the ground. The loss of a modern, meticulously maintained jumbo jet in clear skies created an investigative challenge that defied immediate explanation. NTSB investigators initially suspected a catastrophic internal explosion. They arrived at the site looking for evidence of an engine that had seized or disintegrated midair. Examination of the left engine wreckage showed it was in perfect working order prior to impact. The structural failure occurred at the pylon, the connection point where the engine met the wing. Investigators traced the history of the aircraft back several weeks to a routine maintenance check. To save time, mechanics had used a forklift to remove the engine and pylon as a single unit, bypassing the manufacturer's strict requirement to remove them separately. This schematic illustrates the pylon mount. The upward pressure of the forklift placed immense stress on the metal, creating microscopic cracks. These fractures were invisible during standard visual inspections. Those hairline fractures sat undisturbed for weeks. A single maintenance workaround, designed to save a few hours of labor, had compromised the structural integrity of a 300,000-pound aircraft. As Flight 191 reached takeoff speed, the physical stress of forward thrust became too much. The fractured mount snapped. As the engine broke away, it ripped through the internal wing structure, severing the primary hydraulic lines and electrical wiring. This caused an immediate loss of pressure. The hydraulic fluid responsible for controlling the left wing's moving parts drained out into the open air. This cross-section shows a leading-edge slat. These extend to increase lift at low speeds, but without hydraulic pressure to lock them in place, the oncoming air physically pushed the left wing slats backward into their retract position. This vector view illustrates the result. The right wing continued to generate lift, but the air over the left wing became turbulent and failed. This aerodynamic asymmetry forced the jet into a roll the pilots could not correct. Engineers designed the DC-10 with multiple safety redundancies to prevent a total loss of control, yet a linear, sequential chain reaction, born from a single maintenance decision, rendered every one of those safeguards useless. Once the NTSB identified the cause, the FAA took the rare step of grounding every DC-10 operating in the United States. Fleet-wide inspections revealed a terrifying reality. Multiple other aircraft were found with similar hidden cracks in their engine mounts, all caused by the same maintenance shortcut. The industry responded by completely rewriting maintenance procedures. Regulations were strengthened to outlaw unapproved workarounds and mandate more rigorous inspection methods for engine pylons. It is a grim reality of modern flight that safety protocols are reactive. Today's exhaustive checklists and strict regulations were written in the aftermath of tragedies like this one. Flight 191 remains the most devastating evidence that in high-stakes engineering, even the smallest shortcut carries a catastrophic cost.